Alrighty, so let's talk about some applications of electric fields and electrostatics. What the heck is it good for? It's not just good for tormenting grade 11 students, although it's doing a really good job at that. So figure 1 illustrates an office copier. The copying process is called xerography, from the Greek words xeros and graphos, meaning dry writing. The company Xerox gets its name from the process xerography. And I don't know why it's pronounced with a Z. You'd think it would be an X, but I don't know how to say it with an X. Does anyone want to give it a go?
Xerography.
Yeah, something like that, right? Xerography? Xerography sounds a little more sophisticated. Yes. So, the heart of the machine is the xerographic drum, an aluminum cylinder coated with a layer of selenium. So it's aluminum, and it's got selenium on the outside. Aluminum is an excellent electrical conductor. What does that mean? It means electricity will flow through it, right? Selenium, on the other hand, is what we call a photoconductor. It's an insulator in the dark. So if it's dark, electricity will not pass through it. If it's light, electricity will pass through it. Okay? Aluminum just does it all the time. So consequently, if a positive charge is deposited on the selenium surface, the charge will remain there provided that the selenium is kept in the dark. If the drum is exposed to light, however, electrons from the aluminum pass through the conducting selenium and neutralize the positive charge. The photoconductive property of selenium lies at the core of the xerographic process. So figure 2 illustrates the 5 steps of the process. And here's a picture right here, and there's sort of the 5 steps at the bottom. First, an electrode called a corotron gives the entire selenium surface a positive charge in the dark. So down here in the diagram right here, you can see this big drum right here. That's the drum that's coated in selenium. The entire thing is given a positive charge in the dark. Okay? Second, a series of lenses and mirrors focuses an image of a document onto the revolving drum. So for example, down here, you want to photocopy a giant number 3, because we don't have enough 3's in the world. Okay? So down here, we've got the selenium-coated drum. Can you see the little positive charges on there in your diagram? And then, when you press the start button on your photocopier, the big 3 is the image is sort of shown onto the lens. Now what happens when the light shines through? Well, when there's just paper, the light goes right on through, but where it's dark, where the 3 is, it's kept in the dark on the selenium drum. So what happens to when the selenium here in this area here, that's in the light, the negative charges that are on the aluminum will sort of neutralize the positive, and you end up with a big giant 3 that you can't see, but it's really just made up of positive charges. So you get a big giant 3 made up of positive charges on the drum. Does that make sense? Okay? Okay. So a series of lenses and mirrors focuses an image of a document onto the revolving drum. The dark and light areas of the document produce corresponding areas on the drum, i.e. you get a big giant 3 of positive charge. The dark areas retain their positive charge, but the light areas become conducting, lose their positive charge, ending up neutralized. Thus, a positive charge image of the document remains on the selenium surface. Now it's true whether or not it's a big giant 3 or whether it's a sheet like I just handed you, right? It's hard to believe it works that well, actually. Right? Because imagine, like how much dark is there really as the light shines through? It's actually very impressive that it works.
How did it be colored?
That's a different process. Yeah. I'll come back to that.
Actually be colored.
So we get a positive charge image of the document arranged on the selenium surface. In the third step, a special dry black powder called the toner, and you've seen that, right? Maybe it comes in the big plastic jugs, and you got to feed the photocopier, is given a negative charge and then spread onto the drum. So the toner is zapped with static, it's given a negative charge, and it's basically thrown onto the drum. What happens when the negative toner is thrown onto the drum that has a big giant positive 3?
Stick to the positive.
Yeah, exactly. The negative charge sticks to where it was positive, producing an actual big number 3 made up of toner on that drum. Okay, now you can actually see the big number 3. So it spread onto the drum where it adheres selectively to the positively charged areas. The fourth step involves transferring the toner onto a blank piece of paper. How do they do that? The attraction of the positive charge image pulls the toner to the drum. To transfer the toner, the paper is given a greater positive charge than that of the image with the aid of another core charge. So the paper is actually electrically charged, and then the paper and the adhering toner pass through heated pressure rollers, and as a result, the toner melts into the fiber of the paper and produces the finished copy. Okay, so paper comes through, it's given a greater charge, the negative toner jumps onto the paper, and then it actually has to be melted right into the paper, which is why when it comes fresh out of the photocopier, what does it feel like? It's all nice and warm like cookies out of the oven, isn't it? Right? And that, my friends, is how the photocopier works. Now, was it Riley that asked about color? You, Keelan? Okay, so Keelan was asking about color. It could, I honestly don't know. It could be a combination of that where it actually spreads
Colored toner.
Colored toner that way, and then it goes through again, it puts a different color on. It could actually be that. Or it could probably be more likely like a laser printer or an inkjet, which we're going to talk about. Okay? So yeah, color copies. Actually, photocopiers now are really just scanners and printers. That's all they are. I mean, it's the same kind of physical process, but they become more digitized. Here, it was actually taking a camera image, right? Like an actual lens would actually focus the image on the drum. Now it's more like a scanner. It takes the digital images and it just basically prints it onto the paper. Similar kind of process, but from a digital standpoint kind of thing. Oh yeah, let's talk about laser printers. A laser printer is used with computers to provide high-quality copies of text and graphics. A photocopier really is just a big laser printer now. The laser printer is very similar in operation to the xerographic drum, except the information to be reproduced is not on paper. Instead, the information originates in the computer's memory and is transferred to the printer through a cable. Laser light is used to copy the information onto the selenium aluminum drum. A laser beam focused to a fine point is scanned rapidly from side to side across the rotating drum, as the figure 3 indicates. When the light remains on, the positive charge on the drum is neutralized. As the laser beam moves, the computer turns the beam off at the right moments during each scan to produce the desired positive charge image, which is the letter A in the picture. So it's very, very similar, except the first one, it takes that picture, it produces the positive charge on the drum, it manually produces an image of the number 3 in positive charge with light onto the drum, and then the toner is added on. In the laser one, instead of instead of the focusing of the lenses and whatnot, it basically is a laser that just sort of goes back and forth on the drum, right? And it turns on and off when it needs to. And it basically produces this image after it sort of scans very quickly across the page. Does that make sense? Yeah? And then basically the rest of the process is exactly the same. So you can see how this kind of machine and a laser printer have sort of been combined together to produce really what is a modern 21st century photocopier. It's really a laser printer that's taken a picture of your piece of paper. Okay? Figure 4 shows the general mechanism that turns the laser beam off and on as it scans across the xerographic drum. The light from the laser is sent through a device called a modulator. The modulator also receives the information to be printed from the computer and accordingly either allows the light to pass or blocks it. Thus, the laser output beam from the modulator is turned off and on at rates often exceeding 1 million times per second. That's fast. The output beam is then directed by a series of lenses and mirrors to a rotating polygonal mirror that causes the reflected beam to sweep from side to side on that drum. When the beam reflected from the rotating mirror is directed onto the xerographic drum, the beam scans across the drum and produces the positive charge image, and then it's the same process, right? The toner is thrown onto the drum, makes the image, then the toner is thrown back onto the paper, and then it's melted. So really, the difference between a photocopier and a laser printer is really just in which step? Step number 2 right here. It's how the image gets on the drum. Okay, on an old style photocopier, it's with lenses and mirrors. On a new one or a laser printer, it's with the laser beam. Hence the name laser printer. Okay, you might have an inkjet printer at home. Do? Anyone? Most people, a lot of people do, although people less and less tend to use them, yes. Some people have laser printers at home. The inkjet printers are relatively cheap. The big problem with them is that the ink dries out and, yeah. The inkjet printer is another type of printer that uses electric charge in its operation. This one actually is the most electrical field related. While shuttling back and forth across the paper, the inkjet printhead ejects a thin stream of ink. Figure 5 illustrates the elements of one type of printhead. The ink is forced out of a small nozzle and breaks up into extremely small droplets whose diameters are less than 4/1000th of an inch. That's pretty tiny. Typically, about 150,000 droplets leave the nozzle each second. Travel with a speed of 40 miles an hour toward the paper, so they're really cooking. During their flight, the droplets pass through two electrical components, a charging electrode and the deflection plate, which is a parallel plate capacitor. It's fancy words for an electric field. Let me show you. When the printhead moves over regions of the paper that are not to be inked, the charging electrode is left on and it gives the ink droplets a net charge. So they have like a positive charge. The deflection plates divert the charged droplets into a gutter and thus prevent them from reaching the paper, and then they are recycled. Back for the next time now. Whenever ink is to be placed on the paper, the charging control responding to the computer turns off the charging electrode so the drops do not have a charge. And if I've got, say, a positive charge to my drops and the charging electrode here, say this is positive and this is negative, which way is the electric field? From positive to negative, and so it is down. And what happens? Oh, sorry, my mistake. This is where the electric field is, right? Sorry, I got a little ahead of myself there. They're not charged back here. They're charged in there. Okay. When they get into here, this plate is positive, this plate is negative. Which direction do the drops go if it's positive to negative? Yeah, it pushes them down into a gutter where they're returned back to the ink supply and then reused for the next time. Right? But when you do want ink on the paper, the charging plate is turned off. The ink, this always stays on. This is turned off, and so what happens to the drops? They just go straight through, and they hit the paper, okay? So that printhead goes, like the paper comes through, the printhead goes all the way across for one line kind of thing, prints where it's supposed to, right? Paper moves up on a line, printhead goes back and forth as the paper rolls up. And so it basically prints one line at a time, just like you've seen, right? Inkjet printers are popular because they can produce color copies. This is a pretty old document that I've given you here. Full color printheads use at least 3 nozzles for different colors, usually cyan or blue, magenta, and yellow, and they basically just mix the colors just like you learned in kindergarten, right? What are the primary colors?
Blue and yellow. Red. Red, blue, purple. Red, green. Red, yellow, red. And green.
No,
green? No, green.
There's always a dispute. Actually, my wife and I have had this discussion because there's actually a difference between primary colors and elementary colors we discovered. Am I right, Peyton? And I can't remember the difference, but I remember a huge argument in my house with my kids and my wife and me about what are the 3 main colors and all this stuff. And so, yeah.
What is it then?
I don't remember how it went.
Red.
I think it depends on whether you're mixing or whether you're taking apart. I can't remember, but it was, yeah. It's certainly way beyond kindergarten, that's for sure.
I think that taking apart is red, yellow, and blue
Yeah.
all make white lights together.
Something like that, yes. Right. 3 of them together make white light, but another 3 make black, I think, right?
Red and blue is pretty
Yeah.
cool.
I think the primaries are the opposites of the elementaries, I think, or something like that. I don't know. Anyways, that's how inkjet printers work. All right. You are also going to get, I got a couple more sheets here for you. Actually, you guys get a lot of time today. I hope you guys did some work yesterday. I have, in my hot little hand here, I have electric fields, all types. These are problems where you don't know whether the droplet is balanced or moving or whatever. You have to sort of get it from the problem, sort of like, a buffet kind of thing. I also have extra questions on Millikan. If you really, really, really love these questions and you want more, well, here's some here. I didn't make one for everyone because I don't think everyone loves them as much as I do. But they are here. I'll just let you guys come get those. I will hand these out. That's really it for electric fields. I probably should have started magnetism today, shouldn't I?
No, for sure.
No?
We should just not do magnetism and give us color more Millikan base.
No.
If we just talk about primary colors.
No. Okay, so I'm going to hand these out. I'll give you the rest of the period to ask me some questions, what have you. Tomorrow's Millikan. I'll start the magnetic stuff on Monday.
Tuesday.